session, we will be covering the concept on arithmetic, the first part of the arithmetic. Now, if you would see in the arithmetic, basically we have questions which would, range on something that we did on a very, it's right from the school days. Questions like percentages, ratios, profit and loss, simple interest, compound interest, and then you can say questions on rate and work, time, speed, distance. So more of what we categorize as a word problem. So you'll see most of the question on arithmetic are the word problems. And arithmetic is one area which has a very high weightage when it comes to the test. So you would see nearly around 25% of 25 to 30%, you can say, the questions that you would see on GRE, would be based on the arithmetic part, right? So that is important. This is important from that perspective. And arithmetic questions are the one which you can do it very quickly as compared to some other areas, something like say geometry, because if it is a tricky question on geometry, it would take some time. Something like similarly on the PNC and probability, but arithmetic has a lot of shortcuts. So you can have a multiple alternative ways to work on questions, get around, approximate, substitute back from the options, back solve. So many techniques that you can apply in the questions on arithmetic. So this is one area where you should look at, where you can actually take as much less time as possible. So try to save as many minutes, seconds, I would say, even if minutes is possible, on these questions. I hope that when you deal with some challenging questions like data interpretation, statistics, PNC, and probability, where you would take definitely slightly more than the average time, you have sufficient buffer that you can be generated from such questions. Okay, so even the next couple of sessions, that we'll go through would basically be based on this area itself, the arithmetic. And the simplest and the easiest topic in arithmetic to begin is a percentage. Now, you'll see percentage actually independently of itself has a lot of advantage and applications. So you would have questions which are purely based on percent as a concept. So there are a couple of rules that we need to understand regarding the percentage. There's some shortcut techniques that you can also work on with the percentages, and then the application of percentages. So the more word problems or the word-based problems. So the application of percentages would come in the questions like profit and loss, which is a direct case where you apply the idea of percent to the question. Then, to a great extent, simple interest and compound interest, and the questions like mixtures and allocation, where you see a lot of questions will involve the application and the idea of percentages. Other than this, you will see percentages being very dominating in the DI section. So a lot of DI questions would involve the percentage calculations. So, and there again, although there is an provision of on-screen calculator, but somehow if you're using the calculators, it slows you down a bit. Because if you see on that, just as I said, going and clicking it online and then executing for even smaller calculations, you will end up wasting a lot of time. So we would work out some basic calculation techniques, some basic Vedic maths techniques, which can help you to work on your percentage calculations. And as you see, GRE, they will never ask you questions which would be very calculation heavy, unlike CAT, where in a lot of cases, using calculator makes sense. But on GRE, at least in the arithmetic section, you can easily, get away without using a calculator. You can just do that mentally. So we're going to look at methods which you can work on quickly on a mentally. Oh, shit. इसने लॉगिन किया. Yeah. Hi guys, can you hear me? Hello. Yeah. Sorry, I just got logged out. Okay. Huh. Right. Here we go. So the application of percentages coming into these areas, not only in these ones, but also in DI, and you can see questions on probability, geometry, where you can have the answers asked in terms of percent. What is the percentage area? That is shaded. What percent of the people, out of the total would satisfy the given condition. What is the probability? So probabilities are nothing but the respective percentages values and all that, right? So we can say that it has got a lot of application, and nearly 70 to 80% of the things that we're gonna study, on GRE would somehow or the other, directly or indirectly, will have some kind of a relation with percent. It can be expressed as percent. Now, as we know, to start on, basically a percent is nothing but simply a fraction, right? So if you just go into the very basic definition of what is an x percent, right? Then we can say that an x percent, when you say it's an x percent, this is nothing but basically, a fraction, that is x over a pre-decided denominator of 100. Okay. Now, for today's sessions, generally, as you know, in the last class we have seen, I was writing it out through my tablet, my writing pen. But that's the technical error. I'm not able to, have an access to that one. The writing part, my Vicom thing has malfunctioned, so it's not working out. So I'll be just texting or typing out the things here. Okay, as far as today's session is concerned. So that's something that you need to bear for this session, where we'll do most of the calculation here by just simply typing out the methods. Like here, as if you say x percent, by definition that is nothing but simply a fraction divided by 100. So if I need to write 25%, so I have to express 25% as a fraction. Okay, then all I need to do is just convert or divide that by 100. So I'll write that's 25 divided by 100, which will be equal to 1 by. Okay, so in order to convert a fraction percent to a fraction, you just divide that by 100, reduce it to the lowest form. Whatever you get, that is a percent value. If you need to do the other way, like if I have to write 1 by 5 as a percent, if I have to convert this as a percent, then in order to convert this one in percent, all I need to do is multiply by 100. It's just the reverse. So 1 by 5 into 100, and 5 would cancel 100 20 times, and hence we can say that is equal to 20%. So these are the two very basic rules that we need to apply to the percent, right? Convert percent, divide by 100, whatever fraction, that's the value. And if I have to convert the fraction to a percent, just multiply by 100, cancel off whatever is left, that is the respective percentage value. So you see, there is a very close correlation between fractions, okay, to its required percent. So it works either way. So you can have actually an application and percentage expressed in ratios. We will come to the ratios and we'll see fractions which are also the ratios to percent, and then percents to fractions. You can just use them either way. Okay, writing out fractions in terms of percent and then writing percent in terms of fraction. Okay. And in a lot of cases, you would see if you're doing mental calculations, either way works effectively. So in some cases, when calculation becomes a lot easier in terms of percent, you can always see the fraction in terms of percent. Okay, and whereas if you would say I have to express percentage, calculate percentage, but I use a fractional value of it, then it becomes a lot easier to calculate. We'll just see some examples and try to work out how it would be convenient when to use a fraction and when to use a percent. But that's just the basic definition that we have to the percent. Okay, now moving on to another thing, as we know that there is this corresponding correlation between the fractions and the percent. So there are some standard percentages values that you need to remember for some standard functions. Some values which occur way common, yeah, they're way too common as compared to the other one. So you can relate that to the corresponding percentages and to the corresponding fractions and their percentages and work that out. Okay. So starting off with the first part here, what would I write, or what would be a percentage equivalent of, you know, 1? If I have to express 1, what would be percentage equivalent of 1? 1 would equal 1%. I just have to make this up. Okay. 1 would equal 1%. How would you express 1 as percent? So when I'm looking at the fraction as 1, you need to convert fractions to percent, right? So you multiply by 100, I'll multiply by 100, and that would be equal to 1%. Okay, so you can write this one as a 1%. So this equals 1%. So 100% would be equal to 1. Now you can see how it works actually. If you would write out x, that x can be actually written as x into 1, right? That can be written as x into 1. And then the same thing now can actually write as x into, that's 100 over 100. Okay. Now anything over 100 is actually a percent, and hence which can relate to, 100% of x. You see, if I take 100% of x, basically it's as good as multiplying it by 1. Okay, so that means every value is always 100% of itself. So you can actually write that x equals 100% of itself. Okay, so this is just the expression that I wrote where you could do that. So in a short, if I have to rewrite this, so you can always write a number as 100% of itself. So if I have, let's say, a 36, okay, I'll take the number 36, then I can actually write this 36 is 100% of 36. There is no half like that. So every number is 100% of itself. So now when we say increase a value by a certain percent, let's say increase 36 by 25% or decrease it by 20%. Basically, these are the values we will be just adding or subtracting to the 100%. So in case if the question says, okay, if 20% of x gets added to x, okay, or let's say increase 36 by 25%, which means what I mean here, I have to add this 25% of 36 to 36. Now the 36 is 100% of itself, which means to I'm just want to increase its value from 100% to 125%. So saying that increase 36 by 25%, it simply means I want to make its value, the new value, as 125% of 36. So I can simply say that the new value will be 125% of 36. Now 125% would be 5 by 4. You can simply convert that. So 5 by 4 into 36, 9 6 are 54. 9 5 are 40. So increase it by that much. And as you can then work it out. So at 125%, you can write 125 100, which is 5 by 4. 4 9s are 9 5s are 45. And hence that can be simply written out. So you can, that's how it becomes a lot easier to express. That is simply 5 by 4 into 36, and hence that can be simplified. So 5 by 4 should be finally as 45. Okay. So instead of doing it in two steps, you find the 25% and then add it back to 36. You can simply write this as a product. Okay. This is 125% of that. Similarly, if the question is reduce 36 by 20%, which means I have to reduce 20% of the value of 36 from 30, which is 100%. So that means I need to reduce its value to simply 80%, of 36. So decreasing 36 by 20% is as good as decreasing or making it 80% of its time. Increasing 36 by 25% can mean then you're making it 125%. So these increase and decrease things can actually be seen as a single expression, just one straight shorthand. Okay, now let's go back and check what would be the equivalent percentages values here for these ones. So we saw 1%, or 1 as a fraction is equal to 100%. What would be the fraction percentage value of half? Okay, which would be exactly half of this. So hence that we can write as 50%. So 1 by 2 is 50%. Okay, then what would be the value of 1 by 3? Now, what is the percentage equivalent of 1 by 3? So if you know the decimal values, you just need to multiply that by 100. That would be the corresponding percent value. So how much would 1 by 3 round to? Yeah, 1 by 3 is 0.33333. Recurring decimals multiplied by 100, that will give you 33.3. Right? So 33.23%. Rounded off here, of course, or 34%. In a fraction, it will be 33 1 by 3%. Because 1/3 is the recurring part. Okay, great. 1 by 4. 1 by 4 would be equal to, it's 1/4 of it. We just saw that was 25%. 1/4 is 25%. 1/5 will be equal to this 20% value. 1/6 on the other hand. Okay, you can say that 1/6 is actually half of 1/3, because 1 by 6 you can actually write it as 1 by 2 into 1 by 3. Right? So which is half of 1/3. Now that 1/3 is 33.33, which you can see as 32 plus 1.33. 32 half would be 16, and 1.33 is actually 4 by 3, which will have a half of 2 by 3. So that would be equal to 16.66%. So you can remember 1% is valid in terms of the other. Like here, 1/6 is half. So 32 plus 4/3. 32 half is 16, 4/3 half is 2/3, which would be 0.666, and hence 16.66%. Again, recurring. Okay, now 1 by 7 is an interesting number. I'll talk about that a little later. Okay, but then when we are looking at it as its fractional value, equivalent to a percent, we just approximate. Okay, so what is the percentage approximation of 1 by 7? How much percent does that contribute to? Yes? Anyone? Any guesses what 1 by 7 would be approximately equal to? No, without using calculator. Right? Of course, I can use a calculator. Right. Approximately that will give you 14.28%. Okay, so that is 14.8%. It's a very easy number to remember because it's on 7. Yes, sure. Okay, this 0.14, so which would be, take 4, because that would be exactly 14%. We'll now multiply by 100. So we'll take it at least to 4 decimal values. Okay, so it would be 0.14 and 28. The actual value, if you would see, of 1 by 7 is 0.142857. So if you calculate, okay, 1 by 7 actually, the decimal value of 1 by 7 is 0.142857 recurring. The 3 dot means now it will recur after that. I cannot just put a bar over here in this case. So I'm just putting a 3 dot, which means this is the recurring value. So 0.142857, 14257, 14257, likewise this one. Right, so this keeps repeating again. So we just need only the accuracy till the first 2 decimal parts. We take only the first 4 digits of the decimal, that is 14.28. Now it's again a very interesting number because if you see 1 by 7, the double of 7 is 14 here. Okay. Then the double of 14 is 28. And then the double of 28 is actually 56. Very close. It's just a 7 extra plus 1 instead of 56. If this would have been 56, it would have been a fantastic, pattern that we could have looked at. But it's 7, so double 14, double 28, double 56 plus 1, so 57. So it's an easy number to remember. So 0.142857. Now, if I need to remember its corresponding percent value, it's just 14.28. So 7 hai, uska double 14, and then point double of 14, which is 28. So you will see it's not a very difficult number to remember. So 14.28. Now, for 1 by 8, we can say 1 by 8 is half of 1 by 4, right? 1 by 2 into 1 by 4 is 1 by 8. So we can write 1 by 8 as half of 1 by 4. 1 by 4 is 25%. So 1 by 8 would be half of 25. That's 12.5%. You can say 1 by 8 is 12.5%. Similarly, 1 by 9, you can say is one third of a one third. 1 by 3 into 1 by 3, which will be 33.33 divided by 3, and that's 11.11. Reckoning, of course, percent. And 1 by 3 is reckoning, so is 1 by 9, 11.11. Again, it's a very interesting number. You would see the pattern when we compare it with 11 or 1 by 11. They're called as cyclic numbers. They complement each other, sometimes complement each other. 1 on 10, which is, as we know, 10%. Which will be 100 by 10 exactly. That's 10%. We're going to use this property a lot in calculating layers or percentages mentally. That a 10% of any number just simply corresponds to its 1/10th value. So if I have a number, let's say 560, then I know 10% of 560 is simply 56. Okay, which is just, you look at it, you don't need to calculate. So 10% of any number is there. You just need to either remove a zero from the units place or put a decimal after the units place. So that would be the 10% number. Then 1 over 11. Okay. Now how much is 1 by 11? Any guesses? Anybody? The value of 1 by 11 as a percent? Just like take a hint from 1 by 9. 1 by 9 is 11.11. So what do you think 1 by 11 should be? Good try, Sarang. But then, it's a two-digit thing. Okay. 9.99. 9.99, again, Gauri, would be very close to 10%. Yeah. The value is 0.0909, right? So you use the two decimal places. So 9.09. So 09 doesn't make sense. So that is 9.09. Okay, write them as the two decimal places because the actual decimal value, okay, of 1 by 11 is 0.0909. Right. Okay, it's right. Sorry. What did I write? 3. No. 0.0909. Okay. So when you multiply this by 100, that'll be 09.09. So the 0 in the first doesn't matter, which is 9.0. So you see 1 by 9 is 11.11 and 1 by 11 would be 9.09. They complement each other. Okay. So the ninth is in 11s and the 11th is in 9s with a two-digit place. And then the last one, that's it. We don't need to go a lot more in this. So 1 by 12, okay. 1 by 12 would be half of 1 by 6. You can say 1 by 12 is half of 1 by 6. 1 by 6 is 16.66. So half of that would give 8.33%. So these are some standard percentages values that we will use for a lot of our calculations. Yes, Nilesh, that's 8.33%. Okay, this is the standard fractional value, which is 1 by 2, 1 by 3, 1 by 4, and all that, and the corresponding percentage equivalent of that. Now, besides this, we would also use some more common, percentages values, which are calculated in terms of these constants. So it's like, sorry, like here, if I need to look at the other multiples, so let we have 1 by 2, which is 50%, then 1 by 3 is 33.33%. Then what would be the value again of the other fraction, which is 2 times that, 2 by 3? If 2/3, then it would be equal to double of that, right? Which is 66.66%. That's going to be 66. 1 by 4 is 25%. Then 2 by 4 would be half, 50%. 3 by 4 would be 75%. So I can remember that. 1/5 is 20. Then 2/5 would be 40. 3/5 would be 60. 4/5 would be 80. Anything 5 on 5 or 4 on 4 would always be 100 because that's what we are using. So you can remember the other multiples of it once you know the base value. Now, interestingly, if you look at 1 by 6, okay, which is 16.66, 2/6 actually reduces to 1 by 3 that we know, 33. 3/6 reduces to 1 by 2. We already know that is 50%. Okay. And then 4/6 it reduces to 2 by 3 that we again know 66.66. The only new percentage value that you need to remember for a sixth, you know, which again you see quite commonly, is 5 by 6. So can you tell me what would be the percentage value of 5 by 6? 48.3? No. It's more than 16. It's more than 50%, right? Harshal? 50 से ज़्यादा होगा ना? Definitely. 5 by 6 is very close to 1, which is 100%. Right? Yeah, these are. Okay, 83.33. Yes, correct. Correct. Right. Second, Nandini. Perfect. Now, one simple way is to see, how to manipulate. See, these calculations are more like manipulations, or in a lot of sense, a visual manipulation. So I can say 5 by 6 is just 1/6 less than 100 or than 1, because just add 1/6 more and that would be equal to 6 by 6, which is 100%. So 5/6 I can say is 1 minus 1/6. Agree? Now 1 is 100% and 1/6 is 16.66. So the value of 5/6 I can say is 100 minus 16.66. 100 minus 16 is 84. I'm still left with to subtract 0.666, right? So from 1, another if you take 0.666, you'll leave 0.333. So therefore 83.33%. You can say that 5/6 is actually 83. Another interesting way to look at it is 5 by 6 go. Just think, of multiplying the numerator and denominator by 2. So if I multiply both the numerator and denominator by 2, that becomes 5 into 2, 10 divided by 6 into 2, 12. So 5/6 is also equal to 10 by 12. Now you know 1 by 12 is 8.33%. As we have remembered, that's the base value. So 10 by 12 would be multiplying 8.33 by 10, and hence that would be 83.33%. So you can also say 5 by 6 can be seen as 10 by 12, which is 83.3%. Okay. So it's just about how you can manipulate the known values. So just remember some bare minimum values and then just try to manipulate them, use them again and again somehow to express the other values. Okay. Now 1 by 7, I'll come over and discuss that interestingly. There's a very sweet pattern to that. Looking at 1 by 8. Now, a lot of 1 by 8 values, then multiples, okay, would get repeated in the 1 by 4. So whenever the numerator is even, it's like 2 by 8 is 1 by 4, we know that. 4 by 8 would be 1 by 2, we know that. And 6 by 8 is 3 by 4, again, we know that. So we don't need to bother about, even numerators on 8. We need to remember only for the odd ones. So like 3 by 8. What will be the percentage of 3 by 8? Okay, now let's see a very quick way of looking at that. Now 3 by 8 actually is 2 by 8 plus 1 by 8. You can say, because the even values I already know, right? So 2/8 hai, which is 25. Se kitna zyada hai? 1 by 8, which is 12.5. So you can say 3/8 is simply 25 plus 12.5. That is 37.5%. Right, so 3 by 8 would be 37. Likewise, what will be the value of 5 by 8? 5 by 8 is 4 by 8 plus 1 by 8 again. So this is again 1/8 more than 4/8. 4/8 is, how much would be 4 by 8? of 50%, and then another 1 by 8 more than that, correct? So that is 50% plus another 12.5%. So we are splitting 5 by 8 as 4 by 8, which is 50, plus 1 by 8, which is 12.5. So 50 plus 12.5, perfect setup, that is 62.5%. So I can very simply express this as 62.5%. Okay. Again, remember these percentages because you're gonna see a lot more commonly in this class. Okay. Now, what is the advantage again that we'll see? Okay, how converting these percentages to fractions or vice versa would help you calculate that. Okay, and the last one here is 7 on 8. Now 7 by 8, okay, sorry, in this case would be 75, 6 8, which is 75 plus 1 8, which is 12.5. Now you know the pattern. You can very quickly, okay, generate that. So it would be now 75 plus 12.5. 75 plus 12.5, which is 87.5%. Yeah. Yes, Nilesh, that's correct. 87.5. You can also say this 1 minus 1 by 8, like we did for the sixth one. So 100 minus 12.5, which would be 87.5%. Yeah, for this one. Right. So these are some additional percentages that you need to also keep in mind. And also its equivalent fractions, because you see these fractions or these percent values a lot common. And see where would the advantage come. So if I'm asked to find in an exam, in a question, let's say, I have to deal with the an expression like say find 37.5% of an 88. Okay, now to look at this and calculate as a percentage, as a percent value, is tedious because then I would see normally how you used to do in your school days 37.5 divided by 100 and then multiply that, multiply that by 88, and then you start cancelling off the denominator with the 100 denominator with the numerator and then do all these calculations. Now that was actually one of the worst methods that was at that class, because this process involved two very lengthy processes, a multiplication and then a division. It would make so much sense if you just simply multiply the numerators and then simply divide by the denominator. Dividing by the denominator would simply mean just putting a decimal after two places. Okay, got it. 121. Check your answer. Okay, 33 is correct. So 37.5% of 88. 100% of 88 is going to be 88. Every number is 100% of itself. So 37.5% of 88 is definitely going to be less. Right. Now here, instead of looking at it as a percent, it would be so convenient to look at it as a fraction. So I would say this is simply 3 by 8 into 88. Right. That would be a lot more easy because I see 88 getting cancelled on 8, 11 times, and 11 into 3, 33. Okay. No more, just one step, one short calculation, and you're done. Okay. So simply it's 3/8 of 88 because the percentage equivalent or the fractional equivalent of 37.5% is 3 by 8. Okay. So that becomes so more handy to calculate. Okay, imagine somebody asking you to calculate what is 14.5%. No? Let's say I'm asked to find what is 14.5% of 154. 14.5% of 154. Now that looks giddy, isn't it? So we see that is there's gonna be a too much of calculation. But then if you can correlate this to any standard percent value, okay, you can just do the approximation. I'm asked to find what is 14.5%. Now, do you see any corresponding percentage value which is very close to it? See, the best advantage that you have on GRE is the options, that the options are so widely spaced. There is so much of gap. Correct. If I look at 1 by 7, that's around 14.28%. And 14.5 is slightly more than that. So which I would say would be very, very close to this one, right? So I would simply write this as 1 on 7 into 154. Right. Now 7 goes on 154 because 154 is actually 140 plus 40. So you can say this 144 splits to 140 plus 40, right? Which is nothing but 20 times 40, 140, and 2 times 40, yeah, which is 22. So this would be equal to 22%. Okay, now this is equals to 22. Now, should I mark an option which is bigger, slightly greater or smaller? Because we approximated to 1 by 7. So what you calculated is 14.28. Okay, now the question is, should I go above or below? Which option should I mark? Greater than 22 or less than 20? Right. Now, what is the approximation we did? We approximated to 1 by 7, right, which is 14.28. That is less than 14.5. So 22 is not 14.5, but only 14.28% of that. I need 14.5, which is slightly greater than 14.28. So my answer should be slightly greater than 22. And hence I will go mark an option that is slightly more than 22, not less. Okay. If the question was not 14.5%, but actually 14.2%, the question find 14.2%. Then finding 1 by 7 would be slightly greater because I'm finding 0.28, 14.28, where I need only 14.2. So 22 is slightly more than the required answer. And in that case, I would have marked an option slightly less. Right. So whenever you are approximating, you always see whether you're approximated on the higher side and the lower side, and accordingly choose your option. Okay. So these are some standard percentages, and their fractions where you can quickly interchange and work by doing that. Okay. Now I am okay. Before I rub, in case if you want to take a small note of that, you can do that. Okay. Possibly, if you are taking the screenshots, you can do it. I'll just clear this off and we'll go to the next one. Okay. Okay. Now, looking at some alternate way of finding out these percentages, like instead of just writing it, dividing by 100 and above. Now, tell me, let's say I have a number, say 460. Now, can you tell me three percentages values of 460? Okay, three percentages of 460 that you can calculate without calculation, or that you can know without calculation. You don't need to do any calculation. You look at the number and you know these three percentages values for every given raw number. So for every number ये तीन percentages को directly दिखता ही है, उसके लिए कुछ calculation करेगा सर. So which 3% would always work, right? Sarang, perfect. The 1%, which is 1 by 100, the 1% of it. Second, the 10%, which is 1 by 10, and then the 100%, which is the number itself. So finding 10%, no, 50%, still you will need to calculate. So if the number is something, let's say 43.75, and I'm asked to find out 50%, then I'll need to divide by 2, which involves this, one small step, but there is. I'm saying you just look at the percent number and you know. So even if let's say 43.72, if I look at it, it's 10%, 1%, 100%, you just know it. You don't need to calculate. So these are the base values that we will try to put in. 1, 10, 100. 100% of 460 will be 460. 10% would be divided by 10, which would be 46. And 1% would be simply divided by 100, which is 4.6. Okay. So if I had a value like say 58.75, so 10% of or 100% of this is 58.75. Same number. 10% will be divided by 10. So shift a decimal to the left place, which is 5.875. And 1% would be dividing by 100, would be shifting a decimal by 2 places, which is 0.5875. So you can get these three values directly from anywhere, without actually calculating. Now, if I need to express, 5%, then other values that you can quickly work out. 5% will always be same as half of 10%. So if I have to check what is, 5% of it, you can say this is simply 10% per half. So you know the 10% of this is like say 460. What will be 5% of 460? 10% is 46. So 5% will be half of 46, which is 23. And then any other multiple of 5 would be easily like that. So 5%. Now, if you know 5%, you can also very easily find out 50%. Or a 50% can easily give you also 5%. Right. Just like the difference between 10% and 1% is, the division of 10. So if you know the 10%, you divide it further by 10, you get a 1%. So like here, 10% is 46, 1% is 4.6. So you can say a 1% is 10% by 10. So likewise, if I would say 460, what would have been 50% of it? 100% is 460, 50% would have been 230, and hence 5% would be 230 divided by 10. So you can say 5% is 1/10 of 50%. So every percentage value correspondingly in a multiple of 10 will also give its units value. So 20% will give you 2%. A 30% will give you a 3%. From 40 you can get a 4. From 70 you can get a 7. 90 you can get a 9, and so on. So you don't need to do that separate calculation. You can borrow it, these percentage values from the other more unknown values in terms of its 10. Say for example, if I'm asked to find what is 23% of, let's say, 66. Okay, now what will be the answer? What is 33% of 66? The first thing is simple approximation. Okay. So if the options are way too spared out, I would simply write this as, what is the approximation I'll do for 33%? One third, because we know 1 by 3 is actually 33.33%. So I'll say this is same as 1 by 3 into 66, which is approximately 22. Right, so let's say this is equal to approximately, okay, or I'll say this approximately 22. But the actual answer would be slightly less than 22, because what is needed is 33%, and what I calculated is one third, which is 33.33%. And hence, I have overshot the actual value, so the real answer has to be slightly less. So if the options are quite spaced out, I don't care. I'll just mark an option which is very close to 22, but slightly less than that. But let's say the options are very close. They don't give us much of a difference. Let's say there are two options which are less than 20. Okay. So the options values, let's say, are, in this case, the option values are 21.89, and then the next value is 21.78. Which one would you? Because you see both of them are less than 22 and pretty close. Is it going to be 21.89 or 21.78? Now, if I have this close, okay, good job, Circuit. If it's this close, then I need to actually work out and approximate it, right? Okay. I need to see what would be a simple approximation. And mind you, GRE would have questions of that simple levels. The calculation will not be very tedious when it comes to GRE questions. It would be something very simple which you can do just mentally. Okay, unlike CAT, which would require quite tedious calculations. This one would be pretty stable. So I can split this as a 30% plus a 3%. So this would be a 30% plus a 3%. Now, what is going to be a 30%? So 10% is 6.6. Okay, so 6.6 into 3, 6380.6 into 3, 1.8. So 18 plus 1.8, that is 19.8. So this is the 30%. Now to this 30%, I have to add 3%. Now what would be 3% of this? 3%, I can get it from 30% by just simply dividing it by 10. Yeah, it has to be the multiples of that, which is going to be 1.98. So, so therefore, adding this give you 1.78. Okay, so here again, you would see that you can split out into the percentages. Yeah, using the multiplicity of 3 will also work. You can check that the sum of the digits, 2 1 is 3, 8 7 is 15, okay, whereas 2 1 is 3, 8 9 is 17. So that will not work in there. Okay, so therefore, this will 21.89 can be rejected and 21.7. Interestingly, if I would have made this as 81, then it would have been a very close call. Right. So this is what CAT will do. It'll give you 21.81, 21.7. It make it very close. It will have hardly a difference of 1.3. And again, if you would try to use the logic of dividing it by 3 or being a multiple of 3, 21.81, 21.78, both of them turns out to be a multiple of 3. So I cannot also eliminate on that basis. And they are again pretty close. This is something what happens interestingly. But GMAT gives you a quite, or a GRE, both the tests, as it's a GMAT or a GRE, both of them give you quite a varied difference in the answer options, plus also a lot of elimination ways of deducing them out. So that works. Okay. Now, nextly, let's say if we need to find something like what would be another, say, let's take it randomly, a 50 or let's say 72% of, say, a 5 So what is going to be a 72% of 5 Now, what would be a breakup that we will look at of 72? We can split this as 70 plus 2, right? We can also, that is one way of looking at 72 plus 2. Another is, you can also look at 75% minus 3%. Right, 75 is 3/4, and we see 540 goes on a 4. Yeah, so this can be seen as approximately 75% percent minus a 3%. This can also be seen as a 70%, that we first find out, plus a 2%. Or it can also be seen as, realize that, an 80% minus an 8%. So it all depends how you would like to break it out. Okay, whether 75 minus 3, 70 plus 2, or 80 minus 8. 388.8, yeah, 398. Check. So working out with 80, so 54, I would say, because 8% would give you that easily. So I'll just take out the first difference one. 80%, 80% would be 54 into 8. Okay, now 54 into 8, it's like, multiplying 54 by 8. So that would give you how much? So 4 8 32, okay, and 40, 432 minus, I need to subtract 8%, which is just a decimal, 43. Okay, So this is as good as subtracting, kind of a 40 first. So 432 minus 40 plus, okay, another 3.2, right? So 432 minus 40 would be, subtract a 40, which is going to be a 392, and another 3.2, which is going to be a 388.8. And hence, it should give you a 388. Okay. Or 3/4 of it, you could have divided this by 4 multiplied by 3 and then subtracted another 3%. 3, that would be 16.2. So if it's a 0.2 that you're subtracting, which you can figure that out from an integer value, if 75% is an integer value, you should be left with a 0.8. Now you could look at the options which are ending with 0.8 and then eliminate the other, which would give you only few options. And if there's only one option, then you can directly zero it. So using the units digit method, or the last point, last decimal point, can also help you to eliminate the options. But one of the, the advantage in any of these questions before you solve. So if, we have something like say X% of Y, okay, can I write this as, or would it be equal to Y% of X? Is this true for every possible value? That finding an X% of Y would be same as Y% of X. Will this relationship work for every possible number? Yeah, if you observe, definitely yes, right? Answer them. Because X% of Y is nothing but X divided by 100 into Y. Right. So you would have X over 100 into Y. Now in multiplication, multiplication is commutative, which means X into Y is same as Y into X. Like 3 into 4 is 12, which is same as 4 into 3. So therefore, we can also write this as Y over 100 into X, which will make it Y% of X. So finding X% of Y is very much same as finding Y% of X. So in any percent calculation, the first thing that you should see is which side is easier to calculate. Okay. So if a question reads like, finding, let's take an example. Yeah, if the question is, let's say, what is 82.4, percent of, let's say, a 50. So looking at 82%, 82.4% of 50 would be same as finding a 50% of, 82.4. Correct? Now just see which side looks easier, to work, the left or the right side. 82.4% of 50, although 50 is a very friendly number, okay, I would just still say I have to find 82.4. Whereas if I'll look at the right side, it's just 50% of 82.4, which means I just need to do half of that, and that would simply be 41.2. So 82.4% of 50 is actually 41.2, because that's same as 50% of 82, right? So that's how we can work out with these percentages. Split them into 10%, 1%, and work. It's just a very friendly, and again, you will not see that much of tedious calculation on GRE. The numbers would be very friendly. So you're gonna have not a very difficult thing to work out. Like here, 40 is what percent of it. But then again, be very careful about their language, the way they frame. Okay, so when you write this as a fraction, okay, and to express as a fraction, as a percent, then writing X% of Y, as we did, we discussed that in the previous class. X% of Y, which is a fraction X by Y. Okay, a or if you're saying, let's say, find what is X% of Y, find X% of Y, and what percent of Y is X. Okay, it should still be X by Y. But here, in that case, if you are reading it as x percent of y. Okay? Which means you have to find x is what percent of y. So here you have x as a numerator and y in the denominator. Now that's a very straight thing. The first term, the first number that we're talking is the numerator one and the second is the denominator. But if you have just rephrased that, what percent of y is x? Okay, it's the same thing, which is the fraction x by y. But I'm saying that of part first and the is part second. So the is part is always the numerator, okay, and the of part is a denominator, right? That's it. So check this out. 40 is what percent of it? Yeah, 40 is what percent of 50. So the required fraction is 40, which is the numerator, of 50, which is the denominator. So that's 4 by 5. And we know 4 by 5 is 80%. That's correct. So 80%. 50 is what percent more than 40. So it's not that much. So 50 is what percent more than 40. So how much extra? 50 is than 40. कितना percent है? Yeah, 25. It's not asking 50. If this more was not there, the more word, if I say 50 is what percent of 40, then the fraction would simply be 50 upon 40, which is 5 by 4. That will turn out to be 125%. Okay. Now the question is how much more? Abhi, if this would have been the same number 40, it would be 100%. 50 by 40 is 125%. So how much extra? It is 25% extra. Right. So you can say 50 is also 10 more than 40. The comparing part is with 40. So therefore the difference of 10 with 40. So 10 by 40, which is 1 by 4, and hence 25%. Correct. Or you can say 50 upon 40 is 125%. 100 say 25 ज़्यादा है, so extra part is 25%. Okay, so that works. Now, this is about, again, as we are talking of the change. If we change the numbers, okay, from one base to the other, then it becomes a lot more convenient if we express these changes in terms of percent, because then it becomes a very standard value. Because everyone understands that it is taken to the same common denominator, which is 100. So bringing out the fractional change. So even if, let's say, we changed, take a value, let's say, take an example where we are changing, let's say, an initial value of, let's say, t is changed or increased to a new value 80. Okay, so what is the percent change? You see, the initial value is 50 and the final value that it becomes is 40. So the increase that we have, increase is 30. So the increase is 30, but then there's an increase of 30 is calculated on what base? Is the base 50 or 80? On what base will we take? So this increment 30 is actually added to 50, because that's the initial value, and we added 30 to that initial value, make it 80. So hence, the fraction or the decimal part, or in this case the percentage part, would be taken with 30 on 50. So 30 on 50. Okay, so how much is the percentage increase? So it's increased by 30 on 50 equal to 3 by 5, that is 60%. So it increases by 60%. So in this case, we see the value is increased by 60%, right? The difference is 30 and 30 on 50. So initial is 50, final is 80. So final minus initial upon 100. Now, if it was the other way, you know, you decrease this one. So that same 50, but in this case, it's not an increase, but a decrease. So decreased 80 to 50. Then what would be the percentage decrease? In this case, we are decreasing. But the decrease here is the same absolute value. So the absolute difference in both the cases is the same. You increase 30 in the first case, you decrease by 30 in the second case. It doesn't matter. But the difference here is on what base this is being calculated. So you increased first on 50, but in this case we are decreasing 30 from 80. So the denominator part here is 80. So 30 on 80, which is 3 by 8. Again, we come across 3 by 8. And what's the fractional or the percentage value of 3 by 8? So we calculated 37.5%. So you can see the answer would be totally different depending on what is your base. So in such questions, the word problem, and that is where they try to trick. Okay, they will use a very crafty language, in order to fool you around. Playing off with the ifs and the ins and the outs and all that, trying to make it look a lot more confusing. You need to read it piece by piece. Don't read the whole question as a thing. Just read line by line, keep on relating the expressions, and then solve it about it. Be very careful about what should be the denominator. Okay, percentages calculation is all about the denominators. You need to know what is the off value in that, and hence accordingly write it. So this is the same thing in the above formula that we were talking about. Anything, increase or decrease, you can simply write this as 100% plus or minus the percentage change that you want to bring in. Because every number which is 1, multiplying by 1 is seen as its 100% of itself. So increase a number by 33%, that means we make it 133% of itself, which is 440. And if you say decrease a number by 30%, which means you have to subtract the 30% from the overall 100 value. And hence we need to actually reduce it or make it 70% of it. So these calculations can be seen directly as multiplication. Okay. This is the same compounding formula that we see. That compounding formula comes from nothing but the successive percentage calculation. So if you have initial value and you're increasing it by p%, so which will be p upon 100 into initial value. Take that initial number, and that's 1 plus p upon 100. You repeat it n times, so you get this bracket multiplied n times, and hence to the power n, which is what happens in a compound interest. Okay, and then the percentage change that we use, final value minus initial value into 100%. Right? Okay, now let's move on to some questions. Like here in this case, the stock was initially priced at 200. It came down to 150 the next day. What is the percentage change in the value of stock? What is the percentage decrease it had? Decreased by 50. Okay, the decrease is 50 absolute value on the original initial value of 200. Right, so 50 on 200, which is 1 by 4, that's 25%. Okay, right, so it is 25%. So now let's move on to some GRE type questions. Now, in the last small discussion that I had with Samir, just a small feedback that I've taken. So there were a lot of couple of things where if I need to go a little slow on that one, so I'm trying to work around. So maybe if you found out the last class to be a little fast, okay. So I will try to adjust on that case in that case, and in that way, I would also have some kind of a repetition of those concept of numbers in case if you have either missed on some of it. So And a lot of you also said that you want some more tougher questions, for practice, that we discuss more tough questions. So generally, the second section would turn out to be a lot tougher. So see, the whole program would run like this. The first part that we're doing here is the very basics part. So we deal with some very medium level questions. Then when we finish off with the first run, then we have the same concept with difficult questions. So we have these 320 plus class types, which will have only the challenging questions. It will be from the same area. Yeah. So we have gonna have all those things again done separately. Then we'll have a second run of it with a second class on number system, which will contain only challenging and tougher questions. So the idea is the first section is going to be medium. The first one is like that. The second section would be tough one, and then in the second round, you're going to deal with all of tough questions. Okay. The point here is that since you start with medium questions, you need to keep a very high accuracy. So in the medium section, in the first section, I would say you should target a 20 on 20. You should not be making even a single mistake there. So when you're solving these questions, ensure out of all the questions that we solved, you got all of them right for every class. So for every class that you're practicing, try to hit 100% accuracy in that. Once we run to the first one and the second one, we'll go to then more challenging questions. Where, yeah, it's going to become uh, a, a good contest in there. But as far as the first run, that is these classes are concerned, I would suggest please keep note that we're getting everything right in this. All right, now moving on to this slide. Let's have a look at this. Take a minute to try this out. Yes. What is it? 9%? Yeah, perfect. Okay. So 30 is X% of 20. So first of all, I need to find, what is this X? Right. It says 30 is X% of 20. So how much would be X% or X value? So in this case, if you see X equals 30 as a percent of 20, which is 150, that's 3 by 2. And then, okay, Y is 20% of 30. So 20% of 30. So we need to find the value of Y. Now Y in this case would be equal to 10% of 30 is 3, 20% would be 6, so Y is 6. Right. Now I need to find, okay, what is now Y% of X. So what would be Y% of X? So means I need to find 6% of, okay, we need to find 6% of 150. Now, instead, what you could have simply said, 10% is 15, and hence 60% would have been 15 into 6, that is 90. If 60% is 90, 6% would be 9. And hence that. Or you could say 1% would be 1.5, and 1.5 into 6, which is 15, 6, 90. So hence 1.5 into 6 would be 9. That's 1/10. Now, instead, if it was what is X% of Y? Okay, instead of our question being what is Y% of X, if the question was what is X% of Y, then what would be your answer? Would that make any difference? Finding x% of y is same as finding y% of x. So saying what is 6% of 150 would mean finding 150% of 6. 150% means 50% का increase, 50% half है, 6 का half 3, so 6 plus 3 9. That would have been more direct, correct? Because there you're not dealing with the fractional 6%, but actually integral 150%. 150% of a number is actually 50% increase. Right? तो 6 में उसका 50% 3 का increase, 6 plus 3 9. It would give you the same answer. It's just another way of looking at it. But it would have given the same answer. Okay, it's good. Now let's go on to the next question. Try this out. Yeah. So what's the answer? 20 or 25%? Okay. So that's it's the two different answers you get a lot of times. 20%, 20. An article is sold. That's the selling price, right? Is sold, you know, for at a discount of 5 for 20. So when I say for 20, this 20 was the original price or the final selling price? The 20 that you have is the selling price or the original list price. It was listed at something, and then this way $5 का discount दिया. So this 20 पे 5 का discount देके 15 पे sell किया, or you know you had the original values with, you gave a discount of $5 and then sold for 20. It's so original one is not 20, so it's the selling price, which is 20 after the discount of $5, which means the original value, the list price or the markup that we got, right? The list price is not 20, but actually 20. Okay. The selling price is 20 after the discount. So subtracting 5, you sold at 20. So which means the list price was 25, and hence the percentage discount, you know, is 5 on the original, which is 25, not on 20. Right. Again, as I said, read. It's about the language. So 5 on 25, which is 1 by 5, which is 20%, not 20. The discount in this case is 20%. If you would have taken this, the original number that you will say, now 5. If you end up taking 5 on 20 during that, then you get 1 by 4, which is 24. Okay, whereas the original is not 20 but 25, and hence that. Right, so if you look at the options, That is 20%. I see a lot of you ended up wanting 25 also, right? 20, 25, yeah. So some of all of you who mark 25 again, be careful. It is only about the language. As I said, the only mistake that you can make on GRE is a silly mistake, something that you misread, and that's nothing as a tough thing on GRE. It's all very simple. Okay, now let's look at this comparison question. Let's try this. Okay, D for most of you, and that's right. Okay, D is the correct answer because we don't know exactly what is the split up of the 16. So how do we calculate these percentages? So, the combined value of a pen and a notebook is $60. So it could be 30/30, right? And the profit, 15% of 30 and 25% of 30 would make notebook greater, But it can also happen that you have pen costing for $50 and the notebook only for $10. Might be a costlier product. So you can have A also bigger than B. And then you can have option A, option B. You're choosing a certain breakup. You can also make them equal. 50% of X equals to 25% of Y. Split an X and Y ratio, 62, and hence you can also get that. So A, B, C, anything is possible, right? So hence the answer option B. Okay, next one. Let's look at the next one. So where we look at successive percent change. Now, if something is changed by first an A% and then by B%, you know, one after the other. So you first gave an X% let's say discount, and then further on you again gave another B% discount. Then the net effective percentage change in that value is given by A plus B plus AB upon 100. Okay, the upon 100 is only for the product AB. Okay, not on the entire sum. So that will be the whole effective percentage change that you will find. Okay, so we can look at this question simply as a form like, let's take a number 100. We take a number 100. You increase it first by 10%. I increase this first by 10%. That gave you 110. Then you further on this one, you increase it by another 20%. So first increase by 10% and by 20%. Now 10% of 11, 110 is 11, so 20%, 22. So adding another 20. So this was adding a 10 here. Simple. So that here adding a 22. So 110 and 22, this is 132. So I got the final value as 132. So what is the effective percentage increase? If I would have to increase it directly by a single percentage, then what would be the percentage? So 100 initially is now becoming 132. Finally, you see there is an increase of 32%. So you can say effectively it's same as 50% increase. Now here, taking numbers and working it out step by step, I could see here something. Now increase है तो we take it positive. अगर decrease होता we keep it negative. So increasing it by 10%. So this is plus 10. A is 10. Again second we increase by 20%. So B is 20. Plus 20 that we have plus A into B, which is 200. So you see that is a 200 on 100, which is 2. Right. So when you add, you see 10 plus 20, which is 30, 30 by 2, 32%. So instead of taking numbers and then working out, you could have just simply substituted, added and subtracted. Okay, it works in all the types of successive percentage calculations. Okay, now you need to be very much sign sensitive when you need to use this formula. An increase should be an increase taken positive, whereas the decrease is taken as negative. So you need to be careful, whether you're taking the increase or the decrease thing or not. Let's say if you first increase by 10%, and then you decreased it by 20%. So the first thing would be increase to plus, second is a decrease, so it's 20%. Now what would be the difference there? So if you take the numbers, if you work out 100 original value, increase by 10%, 110, decrease by 20%, which is 22. I need to subtract 22 to that, which will be 88. Okay. So number 100 finally reduces to 88. So what is the effective change? See, the effective change is 12% decrease. So reduce by 12 overall. So although I increased first by 10%, but then I subtracted 20%, 20% of a larger number. So increase by plus 10 and then you decrease by minus 22. Effectively, it gave me a difference of minus 12. So hence it brought a minus 12 ka difference. So here even if you substitute, you will see this is 10 minus this is 20 and here it's going to be a minus 200. Yeah, so a minus because plus into minus would be a minus, so minus 200 on 100, which is a minus. So 10 minus 20 minus 10 and minus 2, which is minus 12 plus. So depending on the increase and the decrease, you need to take the plus and the minus sign accordingly and substitute them. It's not always adding of the positive numbers. Okay. The increases are added, the decreases are subtracted, and hence a value accordingly. Okay. Now let's look at question on this time. Let's start this. Okay. So what are we getting? 25%. Okay. So here we see that he used to sell some articles at some price. Okay. So that's total revenue that I can say, if I'm trying to write this out, you can say that this total revenue, okay, are actually equal to is the number of units that he sells into the price. So that could be brought down like that. So we can say, let's say the revenue generated would be, let's say he used to sell 10, okay, at a price of 10, he used to generate 100. That is his whole revenue. Now he decides to provide a 20% discount on the market price. But what percent must he increase the number of articles? So P reduces by 20%. And then how much will be the increase in N so that his total revenue remains 100, which means I still want the total revenue to be 100. Now I need to find the new N where I have reduced the actual value of the price from 10 by 20%, which is 2. So hence he is now selling at 8. So that would give us N to be equal to 100 divided by 8. 100 divided by 8 is how much? So you see that, you know, how much is that percent? By what percent must he increase his number of articles sold? Okay, so how much n should go? N should be 100 by 8, isn't it? 20% discount on the mark price, so 10 over 8 means 100, right? Final value 100. So it should be how much? 12.5, right? So what is the percentage increase in the number of articles? So earlier he was selling 10 and now you need to sell 12.5. Okay, although it's a decimal, okay, which is not practically feasible. Okay, so you could have taken 100, which would have given you 125 on 100. Okay, so if you would have just taken the articles as 100 here, in that case, 4,000, and then it would have given you price. So 100 articles, you know, a more convenient way. So this would have been 1,000, and hence this thousands, just to make it more practically feasible, which would be 1,000 on 8, that should be 125. So here in CC, he needs to sell now 125 articles. 125, which is 25 more than previous one, which is 100, and hence the percentage change will be 25%. So he has to increase his sales by 25%. Now we'll see more of this in detail, and there's a lot of shortcuts that works for such cases. Even a lot more on a little trickier and tougher questions. That becomes a lot easier instead of taking numbers and working it out. We'll see more of that in the next session. Okay, and just in there. So 25% right answer. So we're going to continue with this one, and we'll have, you know, a lot more to be discussed on the ratios and then its application in SICI and in percentages, percentages in profit and loss in a more complex or a little more tougher side in the next session. Right? Okay. So before we leave, one thing I just need to check. Um Samyuk, is the attendance done, or do I need to take it